Yeah, I guess it's time to start. Another Kubernetes talk. Something we all really like in the past few years. So my name is Artem Semenov, and I'm going to talk about Kubernetes in a regulated environment and regulated industry. So why regulated industry? So I work for a company called Align Technology, and we are makers of Invisalign, which is a solution for moving your teeth to making them straighten. And we also do iTero scanners that are mostly oriented to GPs and orthos and allowing to create 3D models of teeth that later is used in different treatments, like from crowns to actual orthodontic treatments like Invisalign. And what's surprising for quite a few people is that we have more than 700 developers worldwide working on our products internally. So we can easily say that we actually moving teeth with code. And it's all about doing things with code these days. My role, I'm leading infrastructure engineering team at Align, and I'm also leading a team responsible for development productivity and all the tools that we use in our SDLC pipeline. So how we do work? We have fairly modern infrastructure. So we've been running containers in production for more than 3 years. We use public cloud and on-prem. I don't really like world hybrid here because it depends on the load. We pick the right tool for the job. And we run microservices, and all new apps that we've been creating in the last 3-4 years, we can for sure say they're cloud native. Speaking of compliance, we run compliance workloads in containers. So we have our current container platform that is compliant, that works for us for last 3+ years in production. And we do process sensitive data in application deployed in containers. This year, we are in the process of moving to Kubernetes, like a de facto industry standard for container orchestration. There are a few reasons why we are doing that. One main focus is to be on the modern infrastructure that's going to last for a long time, that flexible, reliable, and allowing us to deploy both in any cloud and on-prem. Once we started the conversations, and some teams were, of course, more excited than others to migrate, and Kubernetes is all fancy, and developers love it. And just in a break room, I saw a conversation happening between two engineers. And one was just, oh, we're totally moving to a Kubernetes now. And the other person said, but it's not going to be compliant. And it was a question but how? Everyone is using Kubernetes these days, so how come it can be not compliant? So there are companies in regulated industries doing that, so how come? But instead of being upset about the fact that road to Kubernetes is closed, we actually decided to investigate and understand how to make Kubernetes deployment compliant for many regulations that we follow. So speaking of compliance, I'm going to take one standard as an example. The standard is called HIPAA, and it governs how you should process medical records in United States. We operate globally. There are multiple standards across the globe. Some of them are having nice names. Some of them are just numbers and letters, so it's hard to digest for humans. But they actually talking about pretty much the same things, how to handle patient records in a secure fashion. So if you're thinking about making your setup compliant, you should consider a few controls that needs to be put in place. Some of them are obvious, like you have to authenticate people. Some of them are on how you transfer data, how you process data, how you audit what you are doing. So that's actually quite a few things to talk about and to think about. I don't have enough time, honestly, to cover all of them. But there is one topic that's caught a particular interest of ours in scope of Kubernetes, which is transmission security. So requirement is quite simple to understand, translated to regular human language. So you basically, all your data should be encrypted if it travels through the network. So very easy. So what's special about Kubernetes in that sense? To understand that, we need to get some insights in how Kubernetes networking is working. I'm showing examples using logos and symbols of AWS cloud. That's a cloud provider we like, but that's true for any Kubernetes deployment, even on-prem. So once you have a network request coming to your service, it's basically going through your load balancer on the left here. Then it's getting to your Kubernetes cluster, where ingress controller processes it and redirects to a servers according to its definition, and it's getting processed to a pod running your application. So quite simple. Kubernetes does all the magic, so requests from ingress controller gets to your application pods, does all the load balancer, so all the cool features. Because of that, of course, we love Kubernetes. So to secure that setup, like with any infrastructure, you establish a TLS termination on your load balancer, you establish a TLS termination on your ingress controller, so traffic going from the internet or your internal network gets to load balancer and then your Kubernetes cluster in a secure way. And a lot of people are stopping at this point, and this is completely fine. So let's say we have just one node cluster in our Kubernetes infrastructure, and we get an encrypted request. We terminate TLS connection on ingress controller, and then we have unencrypted traffic that I show in with a dotted line on my slides, and it gets to a particular pod running your Docker container, running your application, and request is being processed. So everything is fine. No unencrypted traffic is traveling through our network. We are in a good shape. But I believe most of the people running Kubernetes cluster having more than one node. So let's add another node in the picture. And what might have happened during the processing of your network request is that traffic from ingress controller on one node will actually travel to a pod in your service deployed to Kubernetes, which is physically on a different node in a cluster, which means Kubernetes, by doing all its magic, will actually transparently redirect an unencrypted traffic from ingress controller on one physical node to a pod deployed to a different node, which means we will have a unencrypted traffic traveling through our network, which may be a problem for compliance. So that's something that is completely not obvious, and I personally was surprised first time I discovered that it's 2019, it's the most popular container orchestrator, and that's how it works. So what we can do about it? A few things. And first, and probably the best option, and option that will fit most of the people in this room, is actually keep it as is. You know, you don't need that kind of level of detail. You don't need to, for your compliance setup, you don't need to worry about that. Or you may have it covered by additional controls. Maybe you're encrypting data on an application layer, or you're running just PCI DSS certified applications. Because apparently, to make them compliant, you just need to secure perimeter. And on this slide, I have a link to a AWS blog post actually discussing that in details, which is a unique case. They normally just issue white papers, and that's it. But in this case, they went into details. And if you have a PCI DSS compliant application running in your VPC that is properly secure, you don't need to worry about traffic traveling between your Kubernetes nodes, which is interesting. So bottom line, maybe it's just fine and we're keeping it as is. If not, like in our case, then there are more options to solve the problem. So you can terminate your TLS connection on your application level or on a pod level in terms of Kubernetes cluster. So traffic is traveling through your infrastructure encrypted, but you have to, which is pretty straightforward, but you have to manage certificates, you have to manage encryption on a pod or container level. It can be done right, but there is a substantial potential for losing of immutability of your infrastructure. If your certificate is baked to your Docker image and you have a staging environment different from your production and you're using different certificates, now you have two different or more than two different versions of your Docker image, which is supposed to be an immutable artifact traveling from dev machine to production. You can avoid that. You can store it externally. You can always import that, but there is extra work that needs to be done. So certainly an option, but too much hassle to manage. What else we can do? What if we can keep all the magic that Kubernetes give us in terms of routing traffic in a cluster and encrypt all of it? And basically set up a secure mesh network between all the nodes in a cluster. Certainly an option. It's hardest one to implement, but it's allowing us to keep application and network separate and configure them separately. We guarantee encryption in this case because that's what our service is doing and not our application, where developers may have forgot about that. And as I said, that's the hardest option. So to sum up, what we can do to solve that Kubernetes network encryption problem? Just nothing, keep it as is. We can manage everything ourselves and do encryption on a pod level, or we can try to implement a secure networking for our Kubernetes cluster. We went for the option number 3, because we were already using infrastructure on our legacy container platform where we were not terminating TLS on our pod level, so we decided to keep that, and we went for option 3. And we did some research on how it can be done on using tools available in the modern market. So how we can do set up encrypted network in Kubernetes? There are two classes of solutions for that problem. One is CNI-based, which is a custom network interface in Kubernetes. It's basically a solution replacing your default networking in Kubernetes with something else, then can potentially provide encryption on top of that. So major players there that can work for you is a solution from VivNet, is Calico and Flannel, and later two recently joined their force, and there is a project Kernel that trying to take the best things out of both Calico and Flannel and combine them in one solution. Second option is to implement second class of solutions is a proxy-based solutions. Proxy-based solutions are not replacing Kubernetes networking, but rather implementing a service mesh infrastructure for inside your Kubernetes cluster. So major players there are Istio, Linkerd. There are solutions coming from cloud providers, so managed solutions. So I mentioned AWS App Mesh. I'm pretty sure that Google and Microsoft will come up with something similar. And apparently, let's not forget about HashiCorp, because Console is providing a service mesh solution too. It's called Console Connect, and if you're already within relationships with HashiCorp, that can be a very good option for you. How to compare, how to pick what's right for you? That's going to be different depending on your unique case, your unique environment. We did a comparison, we picked solution for us, and your mileage may totally vary. So we took a look on a VivNet and Canal, and the way they're implementing an encryption, for us, that looked like a higher risk because we have experience building our current platform, our legacy container platform at this point. And everything is fine, encryption works fine unless you hit corner cases. Network is slow, network is unreliable, you have issues that are extremely hard to troubleshoot when you have encrypted network setup. So just consider that. Another thing, if you go with CNI-based option, is watch for portability. You deploy it on one cloud provider, you deploy it on-prem, and then you decide to add another backend for your infrastructure, and you need to be sure that you will be able to leverage the same encryption solution. maybe you're not. And that can be a huge limiting factors for expanding of your business, so consider that. Another thing, since it's basically your network in your Kubernetes infrastructure and your container infrastructure. So that should work, because if it's not working, none of your applications are working. So you may need to consider commercial support, and the case of VivNet or Canal, or Flanner or Calico, which means you need to establish a relationship with another vendor, and it's extra time, extra hassle, and I'm not talking about price here. On proxy-based, which end up winning for our case, we picked Istio. Istio is supported by major cloud vendors, so you don't have to get any like separate commercial support. It's just going to be supported by AWS or Microsoft or vendors providing managed Kubernetes, like smaller companies. You are free to pick any CNI solution if you are using service mesh, which may be a huge benefit if you're using a managed service or just value-added services from your cloud provider. And it's service mesh. You might not implement it from the day one and even year one, but that's infrastructure that's going to be in place. You will get operational experience for Istio, Linkerd, or solutions that you're going to pick. And once you're ready, once your developers are ready, once your infrastructure is ready, you can just go ahead and implement a service mesh. You have everything for it. All the like blue-green deployments, nice operational stuff, it's going to be already there because you implemented for compliance. But it's the hardest option to implement. So managing Kubernetes is very hard, as we know from famous tweet from Corey. But if you add Istio on top, you basically add a nice line to your CV, but it's really hard to do. Short deep dive into how actually magic happens if you add Istio on top of your Kubernetes infrastructure. Istio is essentially a set of services that's being deployed in your Kubernetes cluster. And while it's extremely flexible solution and it's allowing you to do a lot of controls on how your network is set up, how it works, to solve the problem that I stated earlier, the only thing you need is to set up mutual TLS between your ingress proxy and pods running your containers. Just one thing out of this complexity will make your Kubernetes setup compliant in terms of network being encrypted, traveling between hosts. So for us, final solution was to implement Istio mutual TLS and let Istio manage all the certificates, encryption inside our Kubernetes infrastructure. And that's how we made our Kubernetes setup compliant. So to quickly recap, consider network traffic encryption in your Kubernetes cluster. It's not encrypted by default. There are multiple ways how it can be addressed. And for us, and probably for you, Istio is hardest, but the most flexible answer with added benefits. Thanks a lot. Thanks for coming to my talk. And tell me if I'm missing anything and I'm wrong. Thank you.